Hello, welcome to my video today. Today I'm going to go over this convolutional neural network tutorial by Tensorflow. So this is, it uses this database which is like 60,000 pictures of animals, vehicles, birds, cats, anything. And it loads the library, sets it up, and then it plots in here, prints this. But anyways, I'll just do it. So I use a Docker for my TensorFlow environment. And yeah, so I'm just gonna start it. Yeah, so this, I was having troubles with this yesterday, this line. And I'll show you what was happening. So instead of doing it like this, I was putting it in quotes, which sometimes you do when you load data, but I didn't need it for this, so I was messing it up. And train images, test images, equals train images. Test images. So the next part, I'll just save this. The next part, you load this picture. The only thing is, when I use Docker, I can't use like, well, that I haven't. It doesn't work for me to do is plt.show. So I do plt.save image, and that saves it into the Docker container, and then I transfer it back over into my local directory, and then I can see it. I don't think I'm gonna do that today, but I have it prepared. But it's the same as this, so it's not really that exciting. But I might skip this part and just do the learning, like the model, and see how that goes. So this is the activation, the Relu layer, which is basically like linearizes the nonlinear functions, which is interesting to learn about on this side, because in one of my classes we're using Taylor series expansions to linearize models, and then these layers kind of like take the images and the pixels and spread them out into like a whole vector, and that's how it kind of is able to interpret. the information. But it's interesting for me because, you know, doing the coding examples is a lot different than the theory behind it. So like what's actually going on, and like when you read a textbook or lectures, and read a textbook or lectures, and then like or do the code, it's like harder. It's hard for me to like relate it to what's going on. You know, it's also hard. I find. You know, sure I can do these tutorials, but relating it to real data, that's definitely hard. So my next task with this example is to convert it, or try to use real data instead of the perfect data that they provide. And that, but use the same model that they, in the tutorial they provide, and but with real data. And that's the issue. That's the hard part, you know. So print, and then a couple more lines. And then compile it. And just a little bit, and then we can see if it works. And it's always nice when it works, but typically it doesn't work after the first try. There's usually a couple spelling mistakes at least, usually with me anyways. Then it has another plot, but I'm not going to do it because it's just a bit of a process to view it, and it's not that important. Or maybe it is, who knows. So I'm going to just quickly over, make sure there's no obvious mistakes. If I can see anything. See if it works. Loaded, it's thinking. No, I must have made a mistake. Activation. Yeah, classic. Classic spelling mistake. Since add model add layers. Oh, that's sense, yeah. Dense. Classic. Dense. And there's always some sort of typo. Sparse categorical cross imagery. Cross entropy. Now let's try again. That's why I wanted to do it kind of like this. See real problems instead of have it already work and then train labels not defined. Train labels here. Oh. Yeah, right there. Oh, up a bit. There, labels. You know, instead of having it just, oh, it's already working, you know, no, it's easy. Okay, it's good news. It's a good sign. So it had it, what was it, twice? I guess my next step is to get it to working on real data. Because when the data is presented like this, it's a whole different story. Hopefully it doesn't take too long. So yeah, then it has this. I guess I didn't need the history one if I'm not going to plot it, but I didn't do it last time either, so I don't know. Maybe I could do it, and then just like I said, export it back to the directory, to the local directory from Docker. And then so if you go to the data, so it's 60,000, 30 pretty small images, 50,000 training and 10,000 a test. So it's just these data sets are so perfect, so it's, you know, of course it's easy. Okay, so it finished here. So it goes through these layers, and then it improved accuracy, and then it outputted the accuracy, and then this one was what was that? I'll just double check it. Test loss. Okay, well, that's okay. Just checking it out. And yeah, and that's that. So, like I said, I like to work with so tiny images too. So like your images aren't always going to be tiny. So it's just I have some images and data I want to try to work with, but like I said, getting it from real data into the tutorials that are perfect data seems to be an issue. Another thing that I get confused about is, so it trains it and then tests it, and then it's saying accuracy. So I guess that makes sense. Like 70% of the time it was able to guess it right, but how do you use that? How do I implement that? But it is just things I have to figure out. So let me know if anyone have some insight on being able to apply it more. Like do these tutorials and it's like, yeah, it works. Okay, cool. But how do I make an actual model that I want to use with real data that is useful? But anyways, thanks for tuning in, and until next time, bye for now.